Hi, this presentation is for the 11th International Conference for Internet Technology and Security Transactions. The title of this presentation is An Approach for Detecting Encrypted Insider Attacks on OpenFlow SDN Networks. My name is Alex Orozco. I am assistant professor at Sul Rio Grandense Federal Institute and a doctoral student at Pontifical Catholic University of Rio Grande do Sul. The authors of this work are composed by Charles Neu, me, Regio Michelin, and Avelino Zorzo. Computer networks are broadly demanded due to the increasing popularity of the Internet access. Indeed, devices need communication in order to exchange information. This usage expansion also increases the possibility of malicious utilization of the network that can be promoted by either systems or people. And usually that activity aims to damage the correct network behavior, using the available resources harmfully or illegally, or even to obtain information without proper authorization. Furthermore, intrusion detection systems or IDS are used to monitor, identify, register, and report suspect activity to the system administrator. And in the past years, a wide range of attacks were described in the literature. One of such attacks are insider attacks, or known as insider threats. Besides, usually organizations focus on protecting these systems from external attacks and do not consider inside intruders. One way to reduce this chance of either internal or external attacks would be to provide communication using cryptography. When using cryptography, even if an attacker is able to capture network packets, if the data is transmitted using cryptography, its reading will be hampered or not even possible. Although cryptography reduces overall chances of successful attacks, an attacker could also use cryptography in order to mask an attack. As a consequence, usually the ciphered attack will bypass the protection systems, since traditional IDS do not analyze ciphered packets. Indeed, to the best of knowledge, there are no efficient models of encrypted insider attack detection found in the literature. Then, recent advances of network technologies result in a new network paradigm called software-defined networking or SDN. Due to the dissociation between the data and control planes, the SDN architecture allows to centralize network intelligence, control, and management on an entity called controller. The controller is basically a software application responsible for taking decisions related to network management. Despite of that, it also acts as a physical abstraction, facilitating application development and services responsible for network flow management. It works as a single logical switch used by application, security mechanism, and management. And this management consists of adding and removing entries that define network routes in the flow table. Decentralization gives a global view of the network to the controller, which enables the development of new IDS approaches to detect encrypted attacks. And some of the main controllers are POX, RIO, Floodlight, and OpenDaylight. And therefore, our work proposes a novel approach to detect encrypted insider attacks on OpenFlow SDN networks. The concerns with security and data privacy imply an increase in the use of encrypted traffic. In this way, the traffic of ciphered data tends to be a standard for applications and systems on the Internet in the near future or even nowadays. One way to reduce the chance of either internal or external attacks would be to provide communication using cryptography. A lot of encryption techniques are used to communicate on communication in order to make them more secure, like IS, RSA, ACC, or both wish. The goal is to ensure that four information security principles will be respected. The first one is privacy, where only the authorized recipient can read the message content, for example, to understand a message where the cipher key is needed. Another one is authentication, where the recipient must be able to identify the sender and verify that it was him who sent the message, and it proves their identities. Another one is integrity, where the recipient must be able to determine that the message has not been modified or altered from its original form during the transmission. And last one is non-repudiation, where the objective is to ensure that the sender cannot deny the authorship of the message and the message was received by the specified person or system. Also known as insider threats, it could be used, for example, to steal sensitive data or to damage a company's image. An insider may also be able to compromise system availability by overloading computing resources like network, storage, or processing capacity and performing, for example, denial of service attacks. An insider that perform attacks may have authorized system access and may also know the network architecture and system policies and procedures, which give them an advantage over external attackers. And normally, organizations focus on protecting from external attacks and do not consider insider intruders. Similarly to traditional networks, an SDN signature-based IDS typically cannot analyze encrypted packets, because they need to analyze the payload data that is encrypted. However, anomaly-based IDS may be applied using three main approaches: protocol-based, modification-based, and statistical-based. Protocol-based, also known as stateful protocol analysis, searches deviation from the packets in each state of the protocol. Universal profiles that specify how a given protocol may or may not be used in data transferred are analyzed, and they are based on the protocol specification of software and hardware vendors and also official protocol standards. However, since this type of approach only analyzes whether the protocol is being applied in a proper way, it's not possible to detect attacks that are being performed at the application layer, which are the most widely used. The modification-based consists on changing the encryption protocol and infrastructure to detect attacks in encrypted data in the network. Basically, the key to encrypt and decrypt data is distributed to the IDS. With this key, the IDS can decipher this package payload and analyze it. However, this technique can turn the network vulnerable and the privacy principle may be broken. In addition, it may consume a lot of processing power, which may turn these methods slow and even making it impossible to apply in real environments with large data traffic. Another one, the based on statistical analysis. It's also possible to develop intrusion detection methods using statistical analysis of observable parameters on encrypted data traffic. Moreover, network behavior analysis methods can be applied, and some information like source and destination IP address, besides the used port, the reader field, and payload size are analyzed. It allows detection of denial of service attacks, scams, worms, network policy violations, and not expected service or applications. Another statistical approach for intrusion detection on encrypted data traffic is the development of methods based on packet flows without payload analysis. In this way, some kinds of attacks like scans, DOS, denial of service, worms, and botnets can be detected. The main limitation of current IDS found in the literature is their inability to analyze encrypted data packets or encrypted flows. However, the new method and model introduced by SDN brings new possibilities to address the limitation, allowing the development of new and more effective intrusion detection methods. The OpenFlow protocol, widely adopted in SDN, provides specific messages to get statistical information of an OpenFlow switch. On SDN networks, the OpenFlow version 1.0 protocol provides encryption through TLS, and a controller can request some statistical information to OpenFlow switch, and a specific message, called real state, can be used to collect statistics from the switch flow tables, port, and individual entries in each flow. And it's possible to request statistical information about individual flows as well as aggregate information from multiple flows. In this way, SDN allows the aggregation of statistic log collected from network devices' memory and forwarding them to the controller. Those data can be used as a data source for intrusion detection methods. And for detection, our proposed IDS uses some OpenFlow provided statistic features like average bytes per flow, average packets per flow, growth of single flows, growth of different ports, percent of per flow, and average of flow duration. And besides, destination and source IP address and port numbers of transport layer will be used in order to match traffic flows. Initially, it is necessary to identify encrypted flows, which are under TLS connections. On IPv6 connections, the OpenFlow protocol defines the encrypted payload to have an extension header with a specific flag set to 1. By default, TLS connections are done through the port 6653. Although these fields could be masked, we can use a strategy to detect encrypted data. Then the OpenFlow switch sends the flows to the controller. After this, the flow may be sent to the flow information logger in order to extract the feature using a new flow. It stores the flow information and sends the features of our proposed statistical-based IDS. This IDS performs anomaly detection to verify if the flow has normal or malicious behavior. The presented approach is based on the flow's classification using statistical features from the transport layer level. Hence, it's possible to identify a specific connection representing the unauthorized action that may characterize a malicious activity flow from an insider. And most of the methods for intrusion detection found in the literature use the key DD99 cup dataset for testing and validation. However, this dataset is very old and therefore not suitable for our approach. Besides, recent datasets that provide complete packets with and without insider attacks are not available. Furthermore, we could not find also any dataset with encrypted packets or flows. Therefore, we intend to develop a new testbed in order to build a new dataset with legitimate flows that contain attacks and encrypted flows. This testbed will be based on a mininet architecture, which allows a realistic virtual network creation running real kernel, switch, and application code on a single machine to emulate SDN networks. And Mininet creates virtual hosts by using a process-based virtualization method and the network namespace mechanism. And furthermore, the OpenDaylight platform, which provides a flexible common platform underpinning a wide breadth of application and use cases, will be used as an SDN controller, and it can provide centralized control for any SDN architecture, regardless of hardware and software vendors, and its controller is open source. First, a flow generator will be used to generate flows, encrypted, unencrypted, and attacks on encrypted flows. Then, a method to identify encrypted flows will be applied. Statistical information will be obtained in order to provide a set of log information. A statistic-based IDS method is then used to perform intrusion detection over the selected flows, which are encrypted. In order to evaluate our method, it's important to analyze the accuracy, the false alarm rate, as well as the system overhead introduced on the network. To measure network overhead, OpenFlow messages such as read state, flow stat request, and flow removed message are used to collect flow information. Then, our method is based only on statistical information requested by an SDN OpenDaylight controller to the OpenFlow switches. This strategy will provide a lightweight IDS. As a future work, we will implement this method on a real SDN environment, creating new IDS. The development of the DPI, which allows some encrypted payload information analysis, will help to improve our method by adding a second detection step. And if you have some questions, you can contact Charles Neal. His email is charles.neal@acad.pucrs.br. Thank you all.